Hello and welcome back. In this lecture, we learn how to calculate hydrostatic force on a curved surface. In video 24 and 25, we discussed about calculation of hydrostatic force on a horizontal and vertical surface. For a horizontal plane, the hydrostatic force is related to the height of liquid column, density, gravity and the surface area. For a vertical surface, the resultant hydrostatic force can be related to the height of centroid of the area from free surface. The location of resultant force is related to this centroidal height and moment of inertia of the area about a horizontal axis, passing through its centroid. In this video, we discuss about hydrostatic force on a curved surface. Consider a storage tank with a curved surface PC as shown in figure. The goal is to find an expression for resultant hydrostatic force, F(r), acting on this surface. To do this, let us consider a fluid element, C, B, A as shown in figure. Imagine that this fluid is in static equilibrium with a number of forces acting on it. Force F1, acting on surface AC from fluid left to it, force F2, acting on surface AB from fluid above, and weight of fluid element, W. The resultant of these three forces will be Fr. In order to balance this fluid element, an equivalent reactive force must be developed by the curved surface. Now F1 is hydrostatic force exerted on a horizontal surface AB. F2 is hydrostatic force exerted on a vertical surface AC. We have already discussed how these forces can be calculated. Once we know these, we can calculate Fr. Consider a drainage tank of 1 meter diameter, filled with water as shown in figure. Calculate the hydrostatic force acting on the curved surface per unit length of the pipe. Since the drainage is open to atmospheric pressure, its effects cancel out. In this case, F1 is due to atmospheric pressure and it can be neglected. Now consider the vertical surface AC with unit length. F2 is the horizontal force, and this can be calculated using the equation we have derived. W is the vertical force and it can be calculated as weight of the fluid. Finally, we can calculate the resultant force acting on this curved element. For the same problem, calculate the resultant hydrostatic force on the curved surface indicated. In this case, only the weight of fluid is acting on the surface, as horizontal forces will cancel each other due to the axis of symmetry. For this configuration, calculate the resultant hydrostatic force on surface BC. We will solve this problem in class. Thank you for listening.